Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 25th, 2025, about 2 days ago. This paper introduces a training-free multi-agent framework that lets models collaborate directly in latent space and, in tests, achieves up to 14.6% higher accuracy, reducing output token usage by 70.8 to 83.7% and providing 4 to 4.3 times faster end-to-end inference. The paper is titled Latent Collaboration in Multi-Agent Systems. And as we will see later, the idea of agents sharing pure latent thoughts has some really exciting implications for how we design collaborative model systems. Also, the authors shared a GitHub repo for LatentMAS. Inside, you'll find the full Python code for the latent multi-agent framework, baselines and TextMAS, dataset loaders, prompt templates, and a main run script, plus example logs and LLM integration, so you can directly reproduce their experiments across all the reported benchmarks. Alright, Figure 1 shows that latent space collaboration makes agent teams both more accurate and more efficient than text-based systems. The big performance radar on the left highlights consistent accuracy gains across all 9 benchmarks, so the purple region for latent collaboration dominates the others. In the top right, the speedup bars report end-to-end inference that is roughly 4 times faster on average, because agents avoid heavy text decoding. In the bottom right, the token usage chart reveals that latent collaboration uses about 84% fewer generated tokens overall. Figure 2 shows how the agent team is actually organized when it tackles a question like the boiling point of water on Mars. The top panel depicts a sequential multi-agent system, where planner, critic, refiner, and solver pass their work along in a single pipeline. The bottom panel presents a hierarchical multi-agent system, where separate math, science, and code experts answer in parallel, and a summarizer agent combines their insights into one final response. Figure 3 explains how latent collaboration actually flows between agents. The top strip shows agents passing folders of information, which represent latent communication instead of text messages. The large panel below details agent A1, which generates a sequence of latent thoughts, then maps them back into valid input embeddings through an input-output alignment layer and stores them as key value pairs. Those key value pairs form a latent working memory that agent A2 directly concatenates with its own cache, so its new reasoning is conditioned on both agents without any re-encoding to text. Table 1 makes the punchline very concrete. Across 6 varied tasks, latent collaboration almost always matches or beats text-based agents on accuracy, while slashing tokens and speeding up inference. This table covers the sequential multi-agent setting, where agents pass work in a line, and it shows token usage dropping by roughly 2/3 or more. Table 2 then repeats the story for hierarchical teams, which coordinate specialists in parallel, yet see similarly large efficiency gains. So the big takeaway is that pure latent collaboration lets agent teams share rich internal thoughts directly, which boosts accuracy while cutting tokens and latency dramatically. More broadly, this points toward future agent systems that feel more like tightly coupled brains than chatty bots. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.